Welcome to lesson number 31. Learn C programming on the Raspberry Pi. Well, it's been a while since we did lesson 30, so I think what we'll do is we'll start today just by reviewing a little bit of what we did on lesson 30, because today I'd like to basically complete our discussion on pointers. So let's first go over to the Pi. And I will start up Genie to bring up our code of what we did in lesson 30. And we'll just take a quick look at it. One example we did last day was called point.c. And in this example we had two variables. The first was x, and we initialized it to the character j. They're both character variables. X is a character and p is a pointer to a character, and we initialize p to the address of x. Well, then we print out the address of p, or the address of x rather, which is p, and then we also print out p, or the address of p. And we do a couple more prints here. P we as a pointer and x as a character, and then we print out the value of p as a character, and it should be a j at that point. And then we change x to a k. So for a small time x was equal to k, but we immediately change the value at p to an L. So we're basically changing x right here. And now x is equal to the letter L. Okay, so you can try this again. Make sure you're familiar with it. And the other example we did was an array example. I had an integer array here of 4 values, 1, 3, 5, 7. And we also had a pointer to an integer. Remember that on Intel machines, integers are 4 bytes long. So if you look at basically x here is 4 times 4 would be 16 bytes total. Okay. And then this little for loop here would just print out the array. Nothing fancy. And then we set p to be the address of x at 1. Well, remember, x at 1 is really pointing to 3, because x at 0 is pointing to the 1. So if we set our pointer to point to the second array value here, and then if we print it out, well, we should see a 3, but then we increment p to the next integer. So it looks like in this point here that we're just adding 1 to p, but we're actually moving p over by 4. So it's now pointing to the 5, and we can print that out. Okay? So if we just go to that lesson 30, change directory, lessons -30, we should be able to see the code there. We can probably run array, and you can see that it used to be a 3 and now it's a 5. Okay, and these are just hexadecimal numbers representing addresses in RAM of where these particular variables are located. Okay, so that's what we more or less did last day. Let me start with a new example now. So I'll create a new one here, and I'll just do something simple here. And this time I'll create another integer array, or yeah, okay, why not? Int. I'll just call it array, and I'll initialize it to let's say 2, 4, 6, 8. And I'll also make a pointer star p, and I won't bother initializing it at all. And let me just say ret return 0. I just want to save this file, so I'll just do this. And then I'll say save as, and I want to save it in lesson 31. So create folder. So the name of the folder should be lesson-31. Oops. And the name of my file, I'll just call it array-1.c. Okay. Okay, so let's put some comments in here first about arrays, just so you get the picture of things. The first thing you should know, and I think I've said this before, is that the name, in this case here, the name array is really the address of the first value. So let me just write that down. Array by itself is the address of the beginning of the array. Array by itself is just the address of the beginning of the array. Okay, that's fine. Well, what about if I was to say the address of array at 0 is also the address of the beginning of the array. So basically they're both the same. And in fact, the C language is a little bizarre, but it also allows us to say array is also the address of the beginning of the of the array. So we could say, for example, that array is equal to the address of array bracket 0, and that's equal to the address of array. They're all the same thing. Okay. Well, I mean, it looks like they're the same thing, but there are some differences between a pointer to an integer and an array. So I'll just make a note of that here. An integer array, this is what we have, an integer array is almost the same as a pointer to an integer, but not quite. So an integer array is almost the same as a pointer to an integer, but not quite. So how are they different? Well, let's say they are different because you can assign a value to EL. You can assign a value to the pointer but not to the array. And let me show you what I mean by that. In my code here, I'll say P is equal to ARRAY. Well, let's see if this works. Printf. Value of, well, I could say the value at address P, the value at address P is %D, comma, star P. And let's see what we get. So if I save this guy, I'll go back here to lesson 31, and I will now say C99 array minus O array 1 and see what I get. And I'll run it, and I get the value is 2. So you notice what I set up here is absolutely true, because I set P equal to array, and I said the value at address P is star P, and it gives me a 2 down here. Gives me a 2. Okay, well, I could have just as easily said, let's try that. We'll change it now to the address array. We'll save it. We'll see what we get. Oops. Well, it's a warning message. It's a warning message, so it's still compiled okay. Assignment from incompatible pointer type. Okay. But it still did work. In fact, I can remove array and I'll just compile it again. And if you see, I still have the executable, and it still gives me a 2. In fact, I can even say, we'll get in later as to why that gives me a warning message. It's not that critical right now. But I'll do this, and I'll do a save on that. I'll remove the executable. I will then recompile and run it, and I get the value as 2. So remember, I got a warning message when I did just this. And it said they're incompatible. Remember, here I said an integer array is almost the same as a pointer to an integer. But they're not really. See, what I'm saying here is this is a pointer to an integer, but this is the address of an array. So if I try to equate them, they're going to come out with this warning message. If I try to assign it. Anyway, for the time being, this is okay to think of that. Let's take a look at something else here that we can look at. Let me also print out here. Well, let's go back to some pointer arithmetic. What I want to do is I want to say p plus plus. I want to add 1 to p. What we really mean is add 1 integer length to p. So we're really adding 4 to p. In fact, we can print out p before I do the adding. I'll print out bracket p is %p slash n quote comma p, and then after we add 1, I'll print it out again like this. Okay, so we basically moved p over by 1 integer, which is 4 bytes. And if we moved it over by 1 integer, we should now be at this value 4. Let's see if that works. So I will now compile it again. Oops. Let me get rid of this warning message here. Just do that. And now we'll just execute it. And now you can see that we are at 4 now. And you can see the difference between the two addresses. One was 224 and it went to 228. So the address is incremented by 4. So it seems very strange, you know, because you just increment p here. It looks like we're incrementing p by 1, but because p is a pointer to an integer, we are really incrementing it to the address of the next integer, which means the actual address in RAM is being incremented by 4 bytes. I hope that makes sense. And I think that's probably more or less what we came to discover. Let's see. Oh, there's one more thing we can do before I can finish this off. Let's look at the size of these things. Right here, I will print out the size. Printf bracket quote size of array is %d slash n quote comma size of. Let's see what we get. Oops. Remember, size of is an operator, just like add, subtract, multiply, divide. It's an operator. It's working on the operand array. Okay. So let's try it again. Let's see what we get. And you see the size of the array is 16 bytes, because again it's 4 integers and each integer is 4 bytes. So I'll just write that down. 4 integers by 4 bytes equals 16 bytes total. In fact, if you wanted to, we could also print out, for example, let's print out also the size of just one element. size of array at 0 is %d/n quote comma size of array bracket 0. So I just want to know the size of the first element of the array, like that. And we'll save that, recompile, and run it, and you can see the size of array 0 is now 4. Okay. So, I think this probably covers everything we need to know for the time being about pointers. And so this is a small lesson, but I believe lesson 29, 30, and 31 combined will give you a good introduction to pointers. Lesson 32, I would like to start by looking at using structures and unions. So stay tuned for that. And let me close this lesson off, and I'll